Welcome to topic 9.3, the greenhouse effect. The greenhouse effect is oftentimes misunderstood, mainly because of its association with global climate change. But in fact, the greenhouse effect is a critical life-supporting phenomenon while at the same time being dangerously amplified by human activities. I want to start off our exploration of the greenhouse effect by traveling to two other planets. First, Mercury. Mercury is, of course, the closest planet to the Sun, with an average distance to the Sun of about 58 million kilometers. The surface temperature of Mercury fluctuates dramatically depending on whether or not it's day or night. At night, temperatures drop as low as 170 degrees below 0 Celsius, and during the daytime, temperatures can be as high as 430 degrees Celsius. The next planet out from the Sun is Venus, at almost double the distance, 108 million kilometers. Venus's average surface temperature is 462 degrees Celsius. Its average is far hotter than Mercury's maximum temperature. So even though Mercury is closer to the Sun, what's the reason for this difference? Atmospheres. Atmospheres and their density and composition. The Venusian atmosphere is extremely dense and is 96% carbon dioxide, which we know to be a greenhouse gas. It's pretty clear that atmospheres play a critical role in the greenhouse effect. This is due to the fact that gases within the atmosphere trap heat that would have otherwise escaped out into space. On Earth, greenhouse gases like carbon dioxide and water vapor are responsible for helping to maintain the Earth's average temperature of about 15 degrees Celsius. That's 59 Fahrenheit for Americans. Without our atmosphere, we would see that the Earth's average temperature would be below zero, somewhere around negative 18 degrees Celsius, meaning that life as we know it certainly could not exist. The reason for the name is because the atmosphere can act as a greenhouse. Just as a greenhouse that one might grow plants in traps heat and water vapor for improved plant growth, the Earth's atmosphere does the exact same thing. Of course, what the Earth's atmosphere is doing is accomplishing that task on a significantly larger scale. The process goes as such. Incoming radiation from the Sun helps to warm the Earth's surface. Now, different surfaces of the Earth warm at different rates. Land warms much faster than water does. But the idea is that re-emitting that heat in the form of infrared radiation is then obstructed by greenhouse gases in the atmosphere. Those greenhouse gases then reflect that infrared radiation back to the Earth's surface, helping to maintain a relatively consistent temperature. Many greenhouse gases are naturally occurring, but since the Industrial Revolution began in the 1750s, the combustion of fossil fuels has contributed significantly to the increase of greenhouse gases in the Earth's atmosphere. Those greenhouse gases include things like methane and carbon dioxide, as well as nitrous oxide, all of which have increased. Most of our direct measurements of these gases began in the 1960s and 1970s. And as you can see from each of these models here, carbon dioxide has increased in concentration, as well as nitrous oxide and methane. You may remember from a previous video that chlorofluorocarbons were mentioned as a greenhouse gas, but because of the Montreal Protocol, their use has begun to decline. That's exactly what we can observe in this model here in the blue and red lines. But because chlorofluorocarbons were banned, the introduction of replacement compounds that don't destroy ozone, but are still greenhouse gases, were used. These compounds are set to phase out by the Montreal Protocol by the year 2030. All greenhouse gases have the ability to warm the Earth, but their potential to do so varies. Some greenhouse gases are more potent than others, and therefore may contribute to climate change more significantly than another one. This chart here shows the global warming potential of a variety of greenhouse gases. Global warming potential is a unitless value because it's all in comparison to carbon dioxide. Carbon dioxide is the reference against which all other greenhouse gases are compared. Carbon dioxide has a global warming potential of 1 unit, regardless of the period of time. This makes it possible for us to compare other greenhouse gases like methane. Methane is a significantly more potent greenhouse gas than carbon dioxide is. Those chlorofluorocarbons that were banned by the Montreal Protocol, even more than methane. In addition to burning fossil fuels, humans engage in other activities that also contribute to amplification of the greenhouse effect. One of those is deforestation. Forests and other foliage on Earth act as carbon sinks. By removal of those carbon sinks, that allows for more carbon dioxide to be released into the atmosphere and less carbon dioxide to be assimilated into plant tissue by photosynthesis. Not only that, but deforestation increases the rate of soil erosion, disrupting the soil, allowing for more greenhouse gases to escape soil as well. Large-scale mechanized farming utilizes a lot of fossil fuels and also can help accelerate the rate of soil erosion, releasing greenhouse gases, especially meat production. We learned in an earlier unit about CAFOs, those concentrated animal feeding operations. Here, we're going to explore the relationship between cattle farming and greenhouse gases.
By far and away, the biggest factor in terms of this mass extinction is destroying natural habitat or converting natural habitat into land for food.
The more dependent we are on meat, milk, and eggs, the greater the CO2 and methane emissions. Cattle and ruminants of all kinds produce methane as a byproduct of breaking down grass and other things that they feed on.
So the contractions are pushing this gas out from the stomach, going through here in the one-way valve.
Yes, and after this we collect inside the bag.
So how long has that bag been collecting gas?
Only 2 hours.
Methane is something like 22 times more potent as a climate-changing gas than is CO2, so it doesn't take very much methane to make a difference.
A cow can basically fill up a 55-gallon garbage bag full of methane every day. One cow's not a problem, but now we have 1.5 billion of them. And it's an incredibly inefficient way of producing food. 3/4 of agricultural land is used just to feed livestock. When you factor in everything, the clearing of the land for grazing, feeding, transporting, livestock causes more greenhouse gases than all the direct emissions from the entire transportation sector.
I don't think it's a competition between these problems. I don't think one can be put above the other. It's like saying, well, is global warming worse than ocean acidification, or is fishing all the big fish in the sea worse than polluting it? And I think it'd be foolish to try and single out any one of them to say this is how we're going to fix the planet's problems. We need to fight them on all fronts.
So thanks for watching this very short video. Until next time, take care.